Hello, my name is Brandon Clayton, the Algebra Guy. Today, as you see on your screen, the topic is how to use a distributive property with expressions. So in this lesson, we're going to go over quite a few examples to make sure that we see all types of problems, decimals, fractions, and all the like. So we're going to put it all together here. Let's get to our question screen to discover what we're really after. How to simplify expressions using the distributive property and how to evaluate expressions using the distributive property. We'll do that at the end where we plug in the x value with a actual number to show you that it actually works. So let's get to it. So let's start off by thinking of this situation. Suppose you have three friends who are going to the movies. They each need $9.25 to go to the movies. So that is $9.25. How much do they need all together? You can think about the dollars and quarters separately. So one way you can think about that is they need 3 times 9, which is 27, and 3 times a quarter, which is 75 cents. So in total, they need $27.75. So if you think about doing the math in this way, you're really just thinking of the distributive property, because you took the $9 and separated from the cents, making it $9, and then adding the 25, 25, 25. So that's the distributive property. It would have looked like this: 3 times 9, 25. 3 times 9. If you were to add the 9 and the 25, it would give you 9.25. But when you're distributing, the idea is you separating with this plus sign the dollars from the cents. 3 times 9 is give you 27. 3 times 25 cents is 75 cents. And there we go. So we're going to look at some more problems like this. But mathematically speaking, here's what we're really doing. We're saying that some number times b plus c is going to give you ab, ac. So another way of looking at that, if I can, because this is what you're going to see me doing as I work through these, is you're taking this number on the outside and you're multiplying by that term and by this term. So a times b is ab and a times c is ac. So here the same thing, a times b is ab, and then this is going to be a negative c, so we're going to still carry that negative with negative ac. So all right, enough for the introductions and the idea. Let's actually work some of the problems. All right, first problem. How do you do this one? So this is 3 times x plus 4. That's just simply another, let's say if we had 3 times 4. So 3 times 4 would be the same thing as saying 3 4 times, right? So that's adding 3 4 times. 3 plus 3 plus 3 plus 3. So in this case, we're saying we have x plus 4 3 times. X plus 4, x plus 4, and x plus 4. Now, I'm not using distributive property yet. I'm only illustrating to you what's really going on. I'm going x plus 4 3 different times. And you're going to end up adding all your x's, 1x, 1x, and 1x. That gives you 3 x's. And 4 plus 4 plus 4 is 12. And there's your answer. So there was an easier way we could have worked that. We could have simply distributed this 3 to both terms. 3 times x is 3x. And 3 times a positive 4 is 12. And there you go. So you see how much easier that would be if you are multiplying some quantity like this, especially if you have a variable in there you don't know the value of. If you want to take that whole quantity, you can just distribute that number on the outside instead of adding each term up. So that's the gist of distributing property. All right, so I want to encourage you as we go through these that you work these problems as well. Be pausing it as I pull up the next problem and see if you're getting it right, to let yourself know that you're on track, but also you learn a lot better that way. All right, so this is going to be 6 times 5y, which is 30y, because 6 times 5 is 30, and then 6 times 1, which is 6. And that's all you can do. It's 30y plus 6. Same thing here. 2 times x is 2x. And 2 times a negative 3 is a negative 6. Now we have a fraction. How do you handle that? So we're going to do the same thing. 3 fourths times n is 3 fourths n. Now I just want to make a side note here, because sometimes students get confused when they see this written in different ways. So that's the same thing as writing 3 fourths with the n here. because if you multiply by n, you're going to be multiplying 3 times n, so it's going to be 3n over 4. So you can see it this way and not just with the n on the outside. So that's just a little bonus. I'm gonna keep that in the box over here. Actually, I'm gonna erase it. I don't want nobody to get confused as to what's going on right there. All right, so now we got 3/4 times 12. Well, we come over here, and if you remember 3/4 times 12, how to multiply a fraction and a whole number. Well, we know how to multiply fractions because we can just multiply the numerators, then multiply the denominators. So let's make this whole number into a fraction by putting a 1 on the bottom. So then that's 3 times 12 is 36. 36. And 4 times 1 is 4. And I can simplify this by dividing 36 by 4. 36 divided by 4 is 9. And so 3/4 times 12 is just 9. And there's my answer. All right, so what about if I have a fraction inside of the quantity in those parentheses? We're still going to do the same thing. 8 times 3/8. Well, I'm looking at this. That's pretty easy to me because I know these 8s are going to cancel out and just give me 3x, although it looks complicated. How is that? Because to review what we've done before, 8 is the same thing as 8 over 1. This is 3 over 8. And I know that 8 divided by 8 is 1. So if I worked it out, 8 times 3 is 24. 1 times 8 is 8. 24 divided by 8 is 3. So I still end up with a 3. So if you didn't see that previously, that's what you're going to get. So I've done this first term. Let's multiply 8 times 1/4. So that's the same thing as saying is 8 over 1 times 1 over 4. That's 8 over 4, which is 2. So 3x plus 2. Again, I would have saw that 8 divided by 4 is 2 to see it a much faster way. But in case you didn't, that's how you would do it. All right, so what about a decimal? 100 times 0.3, you can put that in your calculator, or just remember when you multiply a decimal by 100, you're only moving the decimal a number of spaces to the left or right. In this case, this is 100. We're going to move it to the right because it's going to make that number bigger, 2 spaces. So it moves 1, 2. So that leaves me with 30. 100 times 0.3 is going to give me 30. And 100 times 0.25 is going to move this 2 spaces to make that 25Q. And we're done. So much easier. I got a variable, 2 different variables. Well, don't be fooled or confused or frustrated by that, because on purpose, math problems will, tests will show you different ways of working a problem, and just to see if you understand how it works, not just trying to get some answer. So we're still going to go m times n. M times n is mn. M times n. And m times -4 is -4m. Yes, notice that I did attach this sign to that 4. That's going to be a -4 because n minus 4 is the same thing as n plus a -4. These are the same things, so you have to remember that that minus sign is actually can be thought of as a negative sign as well. So here we go. All right, so what if I have the variable on the other side? And sometimes you'll see this, not often, but sometimes you might. You're still going to handle it the same way. You're still going to say p times x is px. And how do you know which one goes first, x or p? In truth, it doesn't matter which one goes first. But generally speaking, you normally put the alphabet that comes first. You put in alphabetical order, basically. So this is going to be p times 8, which is 8p. And there we go. And -2 times 4y is -8y. -2 times 1 is -2. And here's one that's interesting. What do you do with that? Well, you're going to do the same. You're going to distribute the negative. You're going to say negative times a positive y and negative times a positive 4. Well, negative times a positive y, this negative is start off to be a -1 right there. If you need a 1 to make it clear to you what's going on. So that's a -1 times y. That's negative y. And -1 times a positive 5 is -5. All right, so it gets a little bit, I don't want to say more complicated, but we put another number here, right? So how do you distribute this one? Do we go 2x or do we go negative 2x? Well, like I mentioned before, we're going to make sure that sign gets attached to that number because that's actually a negative 2 times x. That's negative 2x. And a negative 2 times 3 give us negative 6. I'm not going to forget to add that 8 on the end. So I can simplify this one because I have two like terms. I have a 6. No, I have a negative 6. And I have an 8. Well, 8 minus 6 is just 2. And I can bring down my negative 2x. That's a plus 2. And notice that I put the variable in front, right? Because, again, algebraic etiquette, if you will, keeps the exponents in the terms in descending order of exponents. So this one has an exponent of 1, and they don't usually write it. It's an exponent of 1. This has an exponent of 0, but they usually write it descending, so we keep it in that order too. And it doesn't matter. Technically, they're both the same, but just know that you'll see it in that order usually. All right, we got two ways. We have to break this down, distribute in two pieces this time. So let's go ahead and do that. 4 times x is 4x. 4 times a negative 8 is a negative 32. Negative 1, right, times x is negative x, and a negative 1 times 3 is a negative 3. Now, problems that students often make a mistake is they will distribute the first one, but sometimes forget to do the second one. They'll say, okay, I already put negative 1 into that thing. But you make sure you distribute to everything that's separated by a negative, or I'm sorry, by a minus sign or a plus sign. If it had, let's do this, times 4. If it had a multiplication or division, you're only going to do 1. You can just do it to the 3 or the 4. But if it's a plus or minus, these are terms now. You need to make sure it gets to every term. All right, we're not done with this because we can combine our x's. 4 and a negative. This is a 1 here. It's understood. So that's going to be 4 minus 1, which is 3x. All right, so done with that one, done with that one. And I got negative 32 minus 3 more. So negative 32 minus 3 more is a negative 35. And we're done with that. All right, so let's evaluate these now. Some people might be skeptical that this actually works without distributing. What if we didn't distribute it? Will we get the same answer? So let's put 10 in here and then show how it would look if we distribute it and see if we get the same answer. So let's put 10 in here. So we end up with 6 times 5 times 10 plus 1. And that gives us 6 times 50 plus 1. And PEMDAS tells us to do the multiplication first before we do addition. So we do 6 times 50, which is 300 plus 1. And I get 301. So will I get 301 if I would have distributed? If I would have distributed, it gets 6 times 5y. It gives me 30y here. 6 times 5y is 30y. And then 6 times 1 right here is just 6. So plus 6. Now let's put the 10 in where the y, 30 times 10 plus 6. Why am I not getting, oh, it's because I got, okay, I see why. I did not distribute correctly. I did the mistake that I said students make. 50, yeah. So I get the 50 here, but I didn't distribute my 6 to this 1 to make that a 6. I was like, I know I'm not about to get the right answer, and why not? So I forgot to distribute. I distributed to this thing just like I said students would do, but I forgot about the one that was in the parentheses up here. So that should make these 6s, and now this becomes 300 plus 6, which is 306. So there you go. Same answer. All right, so let's check it again that this works. We can put a 3 in place of this y, which will give us 4 times 3 is 12. 12 plus 1 is 13, so we get negative 2 times 13. So I'm just kind of skipping some steps, talking through them. Actually, you know what? I'm going to go ahead and write those steps for those who need to see that. So we're going to do 4 times 3 plus 1, and we got negative 2 out here. This time I'm going to make sure I get that 1 on the end. So this is going to be negative 2, 12 plus 1. And I'm going to do what's inside the parentheses this time. Instead of distributing to both of these, PEMDAS tells us to go ahead and add up what's inside of the parentheses, which is what I should have did last time. So we're going to do 12 plus 1 is 13. And negative 2 times 13 is negative 26. Will we get the same answer here? So if we would have distributed, we would have got negative 2 times 4y, which is negative 8y, plus negative 2 times 1, which is negative 2. I want to erase this plus sign since we got a negative there. So we will replace that y with a 3. We get negative times a negative is a positive. 8 times 3 is 24. 24. Oh, why am I making it a negative 3? It's a positive 3. So negative 8 times 3 is a negative 4. Minus 2 more gives me a negative 26. So yep, same exact answer. I believe this is our last one. So what if you have a negative outside again? We treat it like a negative 1. Y plus 5. Negative 1. Replace that y with a 35 plus 5. Do the parentheses first. That gives us 40. And this ends up being negative 40. So if I would have distributed this negative y, we would have ended up with negative y, and negative 1 times 5 is negative 5. We would have ended up with this. So will I get the same answer? Well, let's find out. So negative y minus 5. Let's plug in 35 where the y is. And it ends up getting negative 35 minus 5 more does indeed give us negative 40. So yep, it works out. Did we accomplish our goal? We simplified expressions using the distributive property, and we evaluated. As you saw at the end, we plugged in numbers to actually check to see if it was true, if distributing works, and it definitely does. Guys, thanks for tuning in. I'm Brandon Clayton, the Algebra Guy, and I will see you next lesson.